for part 1, you should be getting A equals to half and B is equals to 2. Any problems in doing that? Yeah?
Where's gradient of tangents?
Why is it great? Because this is the normal. This is perpendicular.
Oh.
Yeah. The tangent at Q08 is perpendicular to 6y equals to 6 minus x. So it's perpendicular to this particular line. Okay, so the gradient of tangent is actually equal to 6. Understand? So please catch the information carefully. If you are a very visual kind of person, you need a graph to guide yourself. Okay. To be honest, just draw any graph, any kind of curve that you like. Okay. Then after that, you have the tangent, and then after that, it says that there is some line 6y equals to 6 minus x that is perpendicular to the tangent. Okay, so if you were to sketch something like that, maybe you will guide yourself in terms of your thought processes better. Then to find the equation of the tangent, y equals y minus t equals 6. That is minus. So y is equals to 6x plus 8 for the equation of the tangent. Okay. Any questions? Yeah. Okay, so let's look at one last question. Then we'll call it the day for this chapter. This chapter is very short. Okay, let's look at exercise 15.1, question 7. Okay, let's understand this question first. Okay, the question wants you to find equations of some vertical line, okay, that meet two curves. Alright, so there's one curve here and then another curve here. Okay, at points where the tangents to the curves are actually parallel to each other. So if you want to illustrate the question itself, okay, so we are looking at the possibility of having two curves. Okay, I have no idea how these curves look like. Okay, then after it says that the tangents are parallel. Okay, maybe let me change this curve. Okay, maybe the other one something like that. Okay, so two curves. So we are looking at tangents that are parallel. So maybe one of it is here. Sorry, my tangent not very well drawn. Okay, maybe I have one tangent that is somewhere over here at this point. Okay, then after that the other tangent, okay, for the curve that is in blue, right? Maybe it is somewhere here. Okay, and then the question says that these two tangents are parallel. Okay, so we have this tangent 1 and this tangent 2. Okay, for different equations of the curve. Okay, the curves are the ones in black and blue. Okay, so we want to then after that, looking at these tangents, we want to find equations of the vertical lines that meet, okay, at points where the tangents to the curves are parallel. So the vertical line that we're looking at is actually like that. Okay, so we need to find what's the equation of a vertical line? X equals to something, right? Okay. So this is what we're trying to find. So essentially we're trying to find the x coordinate, okay, of the place where the tangent meets the curve. Okay, sorry? Not both curves, okay? These tangents are separate. They are just parallel to each other. It doesn't mean that they are the same tangent. Okay, so in this case, they are different tangents. Okay, we are trying to find the points on the curve. Okay, we want to find in particular the x coordinate of the point. You understand? Okay, so let's start on this. Okay, we are given this equation first. So let's go on this one. Okay, something that just now Kami actually pointed out, right? Okay, because in most questions you find that there are two equations, and then if you were to write dy over dx, which y are you referring to? So I was telling him that if you, in such cases, it is best to write down, okay, the equation that you're trying to differentiate, to write it before that. Okay, one line before that, right? Make sure you write the equation that you're referring to, and then you write your dy over dx so that it is clear. Okay, so dy over dx in this case, that will be 3x squared plus 4x minus 4. Okay, then after that, for the other equation, when I differentiate this, okay, this is what we will get. Okay, so we get the derivative of the two different curves. Okay, so essentially we're looking at two different gradients. Okay, and now since we know that they are parallel, it means that the gradients must be the same. Okay, so let me just state it down. Since the tangents are parallel, you can equate the two derivatives. Okay, then we will now solve for the value of x. Yeah, so therefore, okay, the equations of the vertical line will be x equals to 3 and x equals to -1.
So the other equation will be oh wait.
Any questions? What did I say? I say no homework. I will not have it together. Okay, 15.1 due on Friday. Alright, question 5, 6, 9, B and 11. Yes.
Oh my god.
To be confirmed. It's in the date. When are we doing it? It will happen during June.
Oh, so that means O level is only doing.
The O level confirm. All this confirm. Everything is like
come out one.
Yeah. But it will not come out from the table. Okay. Since we have 10 minutes still, I want to return to you your binomial test in case you have forgot. Cixin, your Emacs one is here. I'm sorry. Okay, go ahead, erase the whiteboard.
Oh, I'm supposed to write X, not X. Oh well. I still got it correct. I don't know what. So I should get the answer. You know this is your I got the answer now. Shut up. Oh, never mind.
Shut up.
Okay, generally for question 1, okay, most of you can apply the formula. It is a matter of whether you are careless or not. Okay, so the formula was given to you. Alright, so the application of the formula, okay, then after that you need to simplify it. So most of you know that you have to simplify. Okay, just that I think a few of you might be careless in terms of this negative sign. Okay, which resulted in your answer in part B being affected. Okay, so in order to find the coefficient of x squared, a few of you think of coefficient of x squared solely just based on x times x. Okay, so you only take negative 7 times 12. That's not correct one, right? Because you can take 1 times 60x squared, okay, which this is what I got here. Then after negative 7 times 12x, negative 7x times 12x, that will also give you x squared term. And then after that, lastly, your 21x squared with, 21x squared with 1. Okay,